Here's problem 224. A helicopter descends from a height of 600 meters with a uniform negative acceleration, reaching the ground at rest in 5 minutes. Determine the acceleration of the helicopter and its initial downward velocity. So we have some kind of helicopter, and it's going down with some initial velocity which we don't know. We do know it's going to reach the ground in 5 minutes. So our time is 5 minutes, which we immediately change to seconds, which would be 300 seconds. If we multiply by 60. Our displacement, since our initial velocity is going down, we are going to define the down direction for everything as our positive direction. So our displacement will be a positive 600 meters as we go down in that direction. We don't know our acceleration, even though we're vertical. It's not gravity because we have the engine working against gravity as well, and in fact we're slowing down as we're going down. So we don't know the acceleration. But we do know that we basically end up at rest, so our final velocity is 0. So we do have 3 kinematic variables. This one, time, displacement, and final velocity. And we were asked to find the initial velocity and the acceleration. So we have enough to do it. Let me correct this here. Sounds good. So let's do this. Let's find our initial velocity. We know that displacement should equal initial velocity plus final velocity divided by 2 times time, and we have enough to figure this out. Let's solve this for initial velocity, knowing that our final velocity is actually 0. So we have that initial velocity should equal 2 delta x divided by t in this case. So our initial velocity is going to equal 2 times 600 divided by 300, which would be 2 times 2, or 4 meters per second, which would down in the positive direction. Sounds good. So that's our initial velocity. We know time, we know our final velocity, so we can calculate acceleration. Let's use a simple equation. Final velocity equals initial velocity plus acceleration times time. So our acceleration will equal final minus initial divided by time. That will be our final velocity, which is 0, minus our initial velocity, which is 4, divided by our time, which is 300 seconds. So negative 4 divided by 300 is a negative 0.0133 meters per second squared. So that is the acceleration of the helicopter as it's going down. Everything considered in that, the engine working against gravity, gives us an acceleration of a negative 0.0133 meters per second squared for our acceleration over this interval. Answer.